Alright, so welcome to this Passing the Common Core Algebra Regents prep session. So let's go on to this problem that has to do with linear equations. So, a company that manufactures radios first pays a startup cost and then spends a certain amount of money to manufacture each radio. If the cost of manufacturing our radios is given by the function C of R, okay, equals 5.25 R plus 125, then the value $5.25 best represents what? Well, the first one says the startup cost. The startup cost should be a constant, a unique value, okay? It's a fixed value, so it's not the startup cost. Actually, that would be 125. Okay, the second one, the profit earned from the sales of one radio. First of all, this is not profit, means how much you're making. This is a cost function, okay? So then number 3 says the amount spent to manufacture each radio. Of course, R represents the radios, and 525 basically is how much is gonna cost to manufacture each radio. So the right answer is choice number 3. Okay, cool then. All right, let's move on to the next problem. Oh, that's a lot. Oh, okay, so let's see what it says. A satellite television company charges a one-time installation fee. You see, one-time installation fee is always a fixed number, and a monthly service charge, that's where you have the variable, because every month, right? So the total cost is modeled by the function y equals 40 plus 90x. You already know, okay? So monthly service charge is going to be 90 per month, and then this is a one-time installation fee. You should understand that. Which statement best represents the meaning of each part of the function? All right, so let's see now. Y is the total cost, X is the number of months of service, 90 is the installation fee, and 40 is the service charge per month. Okay, 40 is not the service charge per month. Look, this 40 is the one-time installation fee. All right, choice number 2. Y is the total cost. Yes, the whole function is based on Y. All right, X is the number of months of service. Yes, we got that. $90 per month. Okay. 40 is the installation fee. Of course it is. And 90 is the service charge per month. $90 per month. Okay, we got it. Choice number 2 is the answer. Oh, D. All right. Let's move on. So 113. Well, the next episode is not gonna be 113. Anyways, let's move on. The owner of a small computer repair business has one employee who is paid an hourly rate of $22. Okay, so we pay $22, okay, per hour. The owner estimates his weekly profit using the function P of X equals 8,600 minus 22x. In this function, X represents the number of, well, you have to RTFQ, read the full question, okay, RTFQ. So you read it, and now look at the choices. All right, so let's see now. They want us to know what X represents in this function. Well, 1, computers repair per week. Yup. Remember something. The owner of a small computer repair business has one employee, so that's what they're saying. So, and it is paid $22 per hour. Okay? So no, X does not represent that. We already know what X represents. X represents what? X represents what? The hours, $22 an hour. Okay, so then it cannot be computers repaired. It cannot be customer served per week. Nope. Hours worked per week. Of course, this is what it means. Remember, $22 an hour or per hour. Okay, and he's talking about estimating his weekly profit. Oh, Bex, you nice. I know. All right, let's go on to the next one. It says, The cost of airing a commercial on television is modeled by the function, and we got the function here, 110n plus 900, where n is the number of times the commercial is aired. So we already know that it's going to be $110 per every time the commercial is aired. And I guess, look, this is a number by itself. This number by itself already tells you that this is either a one-time fee, a fixed amount, a startup cost, something, because it's just a number. So regardless whether you have 1, 2, or 0, you're still gonna end up paying this amount when you start. So let's continue. Where n is the number of times the commercial is aired. Based on this model, which statement is true? All right, so let's read the choices. The commercial cost 0 to produce 110 per airing up to 900. No, I don't even understand what it means. 2, the commercial cost of $110, okay, to produce a 900 each time it's aired. No, it's not 900 each time. Look, the 900 only appears once. It doesn't have a variable. This appears a lot. Okay, the commercial cost of 900, yes, it will cost you 900 to produce, and it will cost you $110 each time it's aired. We got it. So 3 is our choice. All right, next question. All right, the cost of belonging to a gym can be modeled by C in terms of M. Okay, C of M. All right, so C of M equals 50M plus 7950. Okay, this is a fixed cost already, and this is amount per whatever. All right, so we don't know. All right, C of M is the total cost for n months. Okay, so m months of membership. State the meaning of the slope and the y-intercept of this function with respect to the cost associated with the gym membership. Sure, that's not a problem. Look, the slope represents the amount paid each month. Wait, the slope? What are you talking about? All right, listen to me. You know how you have y equals mx plus b? You could also have y equals to ax plus b. All right, m and a, oh my God, I need to clear my voice. Let me clear my voice. M and a represent the slope. Okay, the slope is the multiplier of x. And b is the y-intercept, which is a number by itself, which is the fixed cost, the startup cost, the one-time fee, the whatever. And the slope is the amount per month, per week, weekly, per hour, whatever. Okay, good. So then how am I going to write my explanation? Well, the slope okay, so the slope represents the amount paid each month. Okay, so it's $50 a month. And then the y-intercept, which is this, okay, if you were to graph it, this is where you start your graph, okay, this is where the, sorry, not where you start, but this is where it touches the y-axis. So the y-intercept represents the initial cost of membership. So whether you go or not, okay, once you start and become a member, this is gonna be your startup cost. Got it? Cool, then let's move on. All right, a car leaves Albany, New York. Yeah, Albany is in New York, and travels west towards Buffalo. All right, the equation D equals 280 minus 59t can be used to represent the distance D from Buffalo after t hours. So we know what t represents. T represents hours. All right, and look, 59 per hour. We got you with that, right? Nice, cool. In this equation, the 59 represents the what? Well, if the car leaves, right? And 280 must be like the total distance. Okay? And then it will be decreasing by 59t. So what does 59t? 59 per hour. What could that be? The speed of the car. There's nothing else that I can see. Okay? All right, move. Move. All right, next one. A plumber has a set fee. Okay, set fee, that's the startup cost. That's the number that doesn't have the variable. Has a set fee for a house call and charges by the hour for repairs. Yeah, we know that. They're very expensive. The total cost of her services, ooh, the plumber is a she, can be modeled by C of t. Okay, C is a function of t. C of t equals 125t. Okay, we know what this means, plus 95. Which statement about the function are true? All right, so it charges by the hour for repair. So I'm assuming that it charges $125 per hour, and this is the fixed fee. Get it? Understand? All right then. So now, which statement about these functions are true? So I know that the house call fee is basically already $95. The number of hours the job takes is represented by t. Yes, because like it takes 3 hours or whatever. Oh my God! So it's 1, 2, and 3. Holy smokes! Okay, fine. So where is the answer? 1 and 2, no. 1 and 3, no. 2 and 3, no. 1, 2. Oh, nice, beautiful. Number 4 is the choice. Okay, if you want a copy of these handouts, you could make a comment, request it, and I will definitely email it to you. It says, a student plotted the data from a sleep study as shown in the graph below. Okay, so now it says, I don't want to zoom out, but I have to. I hope everybody can see this. Oh, okay. So it says, the student used the equation of the line, and this is the equation of the line, to model the data. What does the rate of change represent in terms of this data? This is the rate of change. All right, and we're talking about average number of hours, okay, of sleep per day, and we're talking about the age in years. So let's talk about it. It represents we were just talking about, look, the rate of change. The rate of change is another word for the slope. So what does this number represent? It says the average number of hours of sleep per day increases by 0.09 per hour per year of age. No, this is negative. It does not increase. The average number of hours of sleep per day, okay, the average number decreases by 0.09 hour per year of age. Yes, that's correct. So the answer is 2. But let's take a look at choice 3. The average number of hours of sleep per day increases by 9.24. No, this is the startup. This is the fixed amount. This is the amount that doesn't change. So no, it will not increase. And again, it will not decrease either by that amount. So boom, we got that. Okay. During a recent snowstorm in Red Hook, New York, Jamie noted that there were 4 inches of snow on the ground at 3 p.m. Okay. And there were 6 inches of snow on the ground by 7 p.m. Okay. If she were to graph this data, what does the slope of the line connecting these 2 points represent in the context of this problem? To be honest, I don't know. But let's see. At 3 o'clock, all right, at 3 o'clock, there were 4 inches. Okay, at 3 p.m., there were 4 inches. Then at 7 p.m., there were 6 inches. All right, so what do I know? That from 3 to 7 is 4 hours. Okay, and it increased the amount from 4 to 6, so it increased by 2 inches. Yes. Okay, so then what can I write about it? There are 2 inches of snow every 4 hours. Make sense? Good. All right, let's move on. Here, Max purchased a box of green tea mints, right? The nutritional label on the box stated that a serving of 3 mints contains a total of 10 calories. On the x below, graph the function c, where c of x, okay, c is a function of x, represents the number of calories in X means? Sure, why not? So, how am I going to do this? I don't know, Becca. If you don't know, then who do you think knows? Nobody, Beker. So how am I gonna solve this problem? That's easy. Okay, first of all, let's see. I'm supposed to graph this data. So what do I know? A serving of 3 mints contains a total of 10 calories. So 3 mints, 10 calories. 6 mints, 20 calories. I hope you understand what I'm doing. Okay, 9 mints, 30 calories. 12 minutes, okay, I get it. 40. Alright, so you see, it goes up by 10 for every 3 minutes. Alright, so now I'm going to graph the data. So it's going to be like this. See that? Alright, so we go and I graphed it. Now what? Now the question. Okay, the question right here. Write an equation that represents C of X. A full box of mints contains... Okay, write an equation that represents C of X. I could do that. Then, a full box of mint contains 180 calories. Use the equation to determine the total number of mints in the box. Okay, that was not difficult. I definitely could do that. So, what do I know? That for every 3 mints, okay, every 3 minutes you get 10 calories. So 10 up and 3 to the right. That's the slope. Okay, so 10 up, changing y over changing x. 10 up, okay, and 3 to the right, x, okay. And then the y-intercept I know is 0, okay, because if you got 0 mints, then you're not getting any calories. Duh. Right then, so this is my equation. So I'm gonna call this what should I call it? What should I call it? Oh, C of X. Okay, so C of X equals, sorry, C of X equals 10 over 3x. And now they want to know that they telling me that a full box contains 180 calories. So use the equation to determine the total number of mints in the box. Sure. No, it does not work like that. Oh no, you're right, it doesn't work like that. Why? Well, think about this. He bought a box of green tea mints, right? That's what it says here. He bought a box of green tea mints. So the nutrition says that for every 3 mints you get 10 calories. Okay, now they're telling me that the full box has 180 calories. Now they're telling me that the full box has 180 calories. So this is 180 right here. So in other words, I should do the following. 180, which is the full box, equals to the number of calories per mint. All right, 10 calories for every 3 mints. Now we're talking. Now I could do two things. I could solve this on the calculator, which is easy. If you ask me, I'll show you. Actually, you know what? Let me show you how to do it on the calculator. So you just press math, and that is only on the TI-84 plus C or plus CE, not on the other ones. So that's it. Look, the equation. So here I'm gonna put 180, and on the other side of the equation I'm gonna put alpha y equals, and I'm gonna put 10 over 3 and then x. Okay, and now I just go and it says okay, so I'm gonna press graph twice, and we got 54. So x equals 54. Now if you're doing it by hand, then my advice would be to just cross multiply. Okay, so 180 times 3 is 540. So we get 540 equaling 10x. And then I divide by 10 on both sides and I get x equaling 54. Okay, we've been through solving equations, so it shouldn't be a problem. All right, cool. By the way, all this information goes here. All right, that's right. So here I'm gonna have to zoom in. I'm gonna look at this individually. Which graph shows a line where each value of y is 3 more than half of x? All right, once again, zoom in, thank God. So which graph shows a line where each value of y is 3 more than x? So let me write it. Y is 3 more than x. Like that? Oh no, 3 more than half of x. Like that. Okay, so let's see. Let's examine this one right here. The slope. We're looking for the slope of 1/2. So in other words, the y is 3 more than half of x. So let's see now. 1, 2, 3, 4, 1, 2. Okay, 4 over 2 is not 1/2. Oh, 4 up. Wait, 4 up and 2 to the right. Nope. Okay, let's try this one. Let me see. 1, 1, 2. 1, 1, 2. 1, 1, 2. Oh my God! Okay, so let's see what the equation here. So the slope here is 1 over 2. Right? The slope. And the y-intercept is 1, 2, 3. Okay. So then this is the function where the value of y is 3 more than half of x. Got it? So basically what I had to, because look, the y-intercept here is 3, okay? The y-intercept here is 3. The y-intercept here is also 3. 1, 2, 3. But you have to understand, it's y is 3 more than half of x. It didn't say more than negative half or more than the opposite of positive half. No, it doesn't say that. It just says more than half of x. So you have to be careful. Always look at the slope. Got it? All right, if you have any questions, you can always comment. All right. The next one. The graph below was created by an employee at a gas station. So this is the graph. Okay. Look at the graph. Got it? All right. Now this. It says, which statement can be justified by using the graph? Well, that's it. If 10 gallons of gas was purchased, 35 was paid. 10 gallons of gas. Number of gallons. 10 gallons of gas, $35 were paid? No. Okay, for every gallon of gas purchased, $3.75 was paid. Okay, in order for me to do this, I will actually need to find the average rate of change, which is basically, we need to find the slope. So what is the change? Let me find two nice numbers. This nice number is right here. Okay, and this nice number is right here. So from 15 to 30, okay, and from 4 to 8. Got it? So from 15 to 30, that's 15. All right, and from, okay, that's the change in y. And from 4 to 8, that's 4. Okay, so half of 15 is 7.50. That will be over 2, right? Half of this. And half of 750, I have no idea, so I'm gonna use my friend here. Okay, 750 divided by 2, 375. So this is 375 per 1. What does this mean? Okay, $3 cost of gas, right? $3.75 per gallon, per 1 gallon. So now going back to our justification, I can say that number 2 is the correct choice. Okay, let's move on. 123. The value of the x-intercept for the graph of 4x minus 5y equals 40 is. Okay, first of all, how do I find the x-intercept? The x-intercept has coordinates of x, 0. The y-intercept has coordinate of 0, b or 0, y. We're looking for the x-intercept, right? So I need to make the y a 0. So I could show you different ways of doing it. In this case, let's just make the 5. Okay, let me see if I can help you a little bit so you can see better. Okay, cool. So the x-intercept happens when y is 0. So let's make y 0. So I'm going to rewrite the equation, okay? So 4x, all right, minus 5 times 0, because y is 0, equals 40. Now, you know that 5 times 0 is 0, so 4x equals 40. I'm going to divide by 4 on both sides, and I get x equal 10. And now I know that the value of the x-intercept for the graph is 10. I bet you didn't know that. Now, is there another way of doing this? Yes, there is another way. But it's kind of complicated, but it's actually the best way I know how to do it. Solve the equation for y. So I'm going to show you how to solve it for y. So my graph is 4x minus 5y equals 40. So I need to solve for y. To solve for y, I only need to do 3 things. Move the loose number to the other side. The loose number is already on the other side. Get rid of the x term by adding or subtracting. So I'm going to subtract 4x on both sides. So it's no longer here, but now it's subtracting over here. So we got that. And now I'm going to divide by -5 everywhere. So my new equation becomes y equals, okay, 4 over 5x minus, because positive times divided by negative is negative, okay, 40 divided by 5 is 8. And then you grab your calculator once you solve for y, and you're going to put it in the calculator. So what am I going to put in the calculator? Let's see. So I'm going to go y equals, and I'm going to put alpha y equals fraction. So 4 over 5x minus 8. I'm going to graph it so you could see it. That's really not helping me. But if we go to the table and we go to where x is 0, okay, and want to look for the for the x-intercept, so that means that the y has to be 0. Okay, boom, we found it. Look, when y is 0, the x-intercept is 10. Simple as that. All right, cool then. Let's move on. Okay. So now, the next question is this one. Which function has the same y? Oh my God, I cannot talk. Okay. Which function has the same y-intercept as the graph below? All right. First of all, what is the y-intercept in this graph? Is 1, 2, 3. So the y-intercept is -3. All right. So how am I gonna find out if Which of these has the same y-intercept? Easy. Solve for y and you'll see. This is already solved for y, so let me rewrite this. 12 over 4 is 3. Right away, I know that it's not the same y-intercept. See that? Okay, so then let's try the next one. If I solve for y, I have to get rid of the loose number. So I get 3y equaling 6x minus 27. Then I have to divide by 3. If I divide 27 by 3, I get negative 9. Because this is going to be the y-intercept. So I get negative 9, so it's not going to work. Oh. Okay, you know what? It's not number 3 either. So let's try number 4. So once again, we subtracted 3 from here. We subtracted from the other side, of course. Then we cancel them out. And when we wrote the equation, we got y equals, okay, 6x minus 3, which matches the y-intercept from our graph right here. See, negative 3, negative 3, negative 3, good. All right, let's